You're listening to Let's Talk Creation with Todd Wood and Paul Garner, the creation show where we learn, grow, and worship.
Well, welcome to another episode of Let's Talk Creation with Paul Garner and Todd Wood. I'm Paul Garner.
And I'm Todd Wood.
Remember to do all of the algorithm-friendly stuff for us. That would be great.
Yep.
All the subscribing, liking, sharing, leaving us positive reviews, all of that stuff. It's very, very helpful to us as we continue to grow our audience. And if you're a new viewer or listener, and we have acquired quite a few of those recently, then you are very welcome. Todd, before we get into what we're doing today, you will notice that I am not in my dining room.
I was gonna point that out. Your dining room seems to have expanded significantly here.
Yes, indeed. Yeah. So I am in the new office in Cambridge.
Wow.
Which is very exciting.
Yeah.
I can't guarantee that every episode we record, I will be here in the office. It partly depends what else is going on and so on. But hopefully, many of our episodes now will be recorded from here. And it's a lovely environment to be in. And you can see all the books behind me. We've moved our library in. And you can see, everything else behind me, all the furniture and stuff. It's just great to have a lovely environment to now work in, meet people, showcase our research, get the library up and running.
Yeah.
It's fantastic. I can't tell you how excited I am about it.
Yeah. I remember those days moving into the new offices for Core Academy, and it was transformative. It really was to move out of the house. That little corner of the house where I had all my junk set up, and actually move into a dedicated facility. It was just revolutionary to the ministry. So may the Lord bless you many years in that space.
Yeah, thank you very much. Because it's going to be a base for our student ministry that we're beginning here in Cambridge. So we've already had a student meeting here, and it's just going to be transformative, as you say.
Yeah.
Anyway, enough about the new office. Today, Todd, we're going to be doing another audience Q&A episode. It's been a while since we last did one of these. We like to do these every now and then because obviously we get lots of comments to our YouTube channel and comments that are emailed into us and so on. And every now and then we like to sort of store them up and then try and do, well, I wouldn't exactly say quick fire answers because neither of us are particularly
we'll ramble on a while
when we do this. We ramble on, but we do try to sort of keep our answers, maybe short as we can, and and answer some of those. Just run through as many of those viewer Q&A questions that we can handle in an hour or however long this episode is. So that's what we're going to do. And today we're just going to, I've kind of divided up the questions a bit so that they sort of make sense for each of us to sort of answer topics that we're perhaps a bit more familiar with. But each of us, I guess, can chip in, if we've got things to say about the questions.
Yeah.
But Todd, why don't you kick us off with your first question, and we'll get right into them.
Yeah, I think I'm looking at your questions. These are all geology. Wait a minute. Scrolling down Todd's questions. There's Todd's questions. All right. So I wanted to start with this question because I think it's really interesting. And this is the question. So it basically sets up a scenario here. A, the most productively studied issues in view of the health of the church.
Yeah.
B, the hardest problems in creation research. So the question is, does B equal A? There's a lot of crossover between them, but I doubt B equals A. So sort of underlying this question, is it really all that important to be researching the hardest problems in creation? And that's I don't remember what video this came in on, but it's a major theme for Core Academy and our work here at our ministry. The idea of the big questions in creation and what do they mean and what do they tell us about God and what do they tell us about creation and theology and the earth and the world and life around us. So is it really productive for us to say that? And this question pops up in the Bible too.
Does it?
It sure does. You might remember a point at which Jesus had visited his friends, Mary and Martha and Lazarus. And Jesus was teaching. Let's imagine a modern setting. He's in the living room, or he's in the sitting room, and he's teaching, and Mary's there, and Martha is in the kitchen making dinner. And Martha comes out and says, "Jesus, will you tell Mary to get up here and come into the kitchen and help me, because I need help. She shouldn't be just lollygagging around, goofing off, listening to you talk, because we'll hear you later." And Jesus basically just says, nah, she's chosen the better thing. And you have your priorities. And it's interesting, he didn't rebuke her priorities. He said, he didn't say that dinner was unimportant. He simply said, no, this is important too. And this is worthy of attention. A more sinister view of this would be when Judas commented after the woman had spilled that incredibly expensive perfume and anointed Jesus' feet with them. And Judas pipes up and says, "Hey, we could have sold that and given the money to the poor." Because, of course, he was skimming off the top. But, yeah, Jesus is not... Jesus, you'll always have the poor with you. You can take care of the poor later. But what this woman has done is a beautiful thing. And we should, we should value that. And insofar as what we do here, exploring these hard problems, I mean, I don't know how to explain it more. It's going to, hopefully, Paul, when our book is done, we've mentioned this before, it is getting close. It's exciting. I mean, we're close, we are down to single-digit chapters to finish and rewriting a bit here and there, but we're close. And I hope that people will be able to read that book and really get the idea behind this notion that studying the hard problems in creation and the challenging questions is really going to lead us to a better appreciation of who God is and what he's about. And I would like to imagine myself as Mary, chasing after salamanders or fossil hominins or whatever. And Jesus saying, no, leave him alone. He's okay. He's chosen wisely. I don't, I can't speak for Jesus, and I don't know for sure, but looking at the way he responds to these kinds of questions in the scripture, you will always have the poor with you. There's always time to serve them. And, I do that myself. I don't talk about it because it's not part of the ministry, but it's not like I'm not doing stuff. So anyway.
Right. Yeah. Do you think what's behind this question might be a concern that the hardest problems in creation, the ones that kind of exercise us as scientists because of our curiosity about the world, are not perhaps the most pressing issues for the average Christian? Maybe the point of the question is, shouldn't we be more focused on things that have some sort of apologetic significance? because interesting though hominin baraminology might be, what about things that are really apologetically difficult that people are sort of facing, and wouldn't it be more productive to focus on those questions? Do you think that might be what's sort of behind this?
It could be, yeah, that could very well be. And for that question, I would say, well, the most potent apologetic we have is the truth.
Right.
And so these kinds of issues that we address at Core Academy particularly, we're looking at the big picture strategy of how do we understand God's creation. It's not a situation where we're trying to answer, whatever it is, little Freddy's question about Lucy skeleton or whatever. That answer comes out of a larger picture of what God is doing in creation, right? Why does Lucy exist? Why does her species exist? Why did God make that kind? How did she end up dead and buried where she is? Why? All those kinds of questions come into contextualizing what Lucy is. It's not enough to say, well, Lucy was just a tree swinging ape, and so not really a relative of humans. That satisfies some people.
Yeah.
But the truth is bigger and more powerful than just a simple answer, I guess.
Yeah.
So
I think we can sometimes focus sort of atomistically on particular issues because they're sort of bugbears, and like you say, miss that bigger picture, because in many ways the most compelling apologetic is going to be that we construct a model that explains the data better overall. If our main focus is just on sort of picking off whatever the latest sort of apologetic sort of objection is, that's a never-ending task. I mean, we're never going to stop doing that,
Right.
We're just going to constantly be sort of taking pot shots at things. And I think what we're trying to do is perhaps a bit more strategic than that, is developing an overarching model that explains the data cogently as a whole.
Right.
But it's an interesting question, I thought, that one.
Yeah.
I thought that was a thoughtful question. Shall we come on to another one?
Yeah, go for it. What do you got?
So somewhat this is about geology. A lot of the questions are about geology, and I guess they're sort of directed more at me. I can't remember which episode this was sort of this was posted on, but it was asking about limestones and shales. So the question says this: you can't get limestone, marl, laminated shale, subaerial sandstone, or chalk to deposit in turbulent or deep water. These things are exclusion to a global flood, and they represent pretty much the entire geologic column.
Oh, uh-oh.
So, now, apart from subaerial sandstone, which we can come on to, what we're dealing with here, I think, is mostly what we'd call fine-grained sedimentary rocks. So these are sedimentary rocks, lime muds, shales and mudstones, rocks that are made up of fine particles. And by fine, I mean kind of silt or clay-sized particles. So these are particles that are just, less than 2 microns across if they're sort of clays.
Are we talking like sugar crystals or ground flour? Where are we at there? Something people
smaller,
would know.
so you wouldn't really see the grains in clays
okay.
with the naked eye.
All right.
So they're less than 2 microns across, and a micron is 1,000th of a millimeter. So very small particles.
Very small. Yep.
So yeah, silts are a bit coarser. So silts are kind of in between a clay and a sand grain. So you can see sand grains, right, with the naked eye. Yeah. And the questioner is right. I mean, these are very abundant rocks. You see various estimates, but they might make up something like 3/4 of the sedimentary record, perhaps. So they're very abundant. And the problem that I think the questioner is kind of drawing out here is that these rocks are typically thought to have formed by the very slow settling of these fine particles through the water column.
Mm-hmm.
And in order to do that, you imagine, you stir up some mud. It takes a long time for the mud to settle because those fine particles, fall out of suspension very, very slowly. And you need quiet water. If you keep stirring the water up, they're not going to settle out of suspension. So you've got this conventional view. You've got all of these rocks, and they require non-turbulent conditions and very slow deposition rates. So that's a significant objection. However, what's really interesting is that in the last few years, that sort of conventional viewpoint about the formation of fine-grained sediments has been challenged by some new research. It turns out that these silt and clay-sized particles are quite susceptible to a process called flocculation. Flocculation is where these grains are kind of sticky and they stick together and they form larger sedimentary particles. They form aggregates, maybe the size of a sand grain or something like that. And of course, they then can be deposited at the same rates that you can deposit sand. And a lot of work has been published on this, where people have done experiments. Jürgen Schieber at the University of Indiana done flume experiments where you can deposit clays and muds in flumes in active currents, and the grains flocculate together. They clump together, and they're actually deposited at current velocities sufficient to deposit sand. And so this has led to what some people have called a paradigm shift in the whole thinking about mudstones. And so many scientists are saying we now need to go back and look at these fine-grained sediments in the geologic record. And when we do that, we begin to actually find some clues that perhaps they were deposited much more rapidly than we thought before. And there are some subtle sort of features of these rocks that indicate sort of rapid deposition rates. And what's also interesting is the same work is also applicable to lime muds that form limestones. So similar work has shown that lime muds also have this tendency to sort of flock together. So that's interesting. Now chalk, the questioner also talks about chalk, and chalk is a particular special kind of limestone. And I know you've been reading about chalk recently, but chalk is made up of billions of shells of tiny marine microorganisms called coccolithophores, and so chalk is often quite pure calcium carbonate. It's sort of just made up of vast numbers of these shells of these marine organisms. But what's interesting is even in the present day, what often happens is these organisms will, when the conditions are just right, when the temperature in the water is right, when the nutrients are just right, when the upwelling, is just right, these things will just explode. Their populations will explode. They'll turn the water white because they just reproduce prolifically, and we call them these things blooms, sort of algal blooms. And these blooms can be so massive, you can actually see them from space. You can see them in kind of satellite imagery, so they can be massive. And I suspect that something like that happened during Noah's flood. I suspect that during the flood, there were times when the conditions in the water column were just right for these microorganisms to just kind of go crazy. And proliferate in vast numbers and produce things like the chalk. And it is interesting that the chalk, you get chalks throughout the geological column, but they're particularly prolific in the Upper Cretaceous. It's almost like this strange event happened, in the Upper Cretaceous to form all of this chalk on a kind of global scale
basis. Wow!
And you get these thick chalks, and they're pure. There's very little sort of mixture of other sediments. You find other macrofossils within the chalk, which are often well preserved, which is itself an indicator that perhaps they were buried quickly within the chalk. We even see evidence now of large-scale current activity. So if you go and look at the chalks along the coast of Normandy in France, you can see that the chalk has got channels carved in it, and it's been piled up into banks. And so there's evidence that this was not simply a kind of placid seafloor where these coccoliths were just sort of raining down from the surface waters and gradually building up. There were currents. This was a dynamic sort of environment. So I think, this when the questioner says you just can't deposit these things in deep water, turbulent conditions, well, I'm not so sure about that, because I think new research on these things is actually casting them in a completely new light.
And I would like to add to that. There's a certain assumption that goes into that as well, that the flood is sort of this uniform depth thing,
right,
all the time.
Yeah,
the entire duration.
Yeah,
and I don't find that to be a very warranted assumption. I'm not sure that would be true. Yes, the Bible describes the waters prevailing up to whatever it is, 15 cubits above the highest mountain.
Yeah.
So sure, it gets up there, but like any flood, it's not going to stay there. It's going to run off the land and back into the basins, and and so I'm just not seeing enough uniformity to the flood to be able to say, no, this could never happen in a flood. Maybe not.
Yeah, we can make very simplistic assumptions about the flood.
Yeah.
And of course, the other thing that the questioner mentions is subaerial sandstones. Now, we won't go into detail about that here. We have actually covered that already in the podcast.
We have, yeah.
And if you go way back to episode 24, we interviewed John Whitmore about the research that he and I and others did in Grand Canyon, looking at the Coconino Sandstone, which is perhaps one of the classic textbook examples of a subaerial sandstone. In other words, a sandstone that was deposited not by water, but by wind. And if you're sort of curious about a creationist take on that particular issue, that particular problem, do go and check out that episode. And I think you'll find that interesting. So,
absolutely. All right. Shall I?
Okay. Do you want to go on to the next another question?
Yeah, absolutely. All right. So this one's going to be complicated because I'm going to have to explain what they're talking about here. But so I have heard that functions have been found for certain endogenous retroviruses. Could the bad ones have arisen as a result of the curse on the ground? Okay, so endogenous retroviruses. What in the world is an endogenous retrovirus? All right, so I don't want to bore you too much with history here, but so as we have learned more about the genomes of big creatures like us, eukaryotic, macrocellular, plants, fungi, animals, and so forth, especially human beings, it turns out that our genomes contain sequences that are strikingly similar to retrovirus genomes. Yeah. And it's not just a few of them. There are lots and lots of these things, hundreds and thousands of endogenous retrovirus sequences, particularly in the human genome. That's where I know them the best. They're in the human genome. So I believe this must go back to one of our natural evil episodes. We'll look that up and link that in there, because that's worth thinking about. But yeah, endogenous retroviruses. So what would be a retrovirus? HIV would be a retrovirus. I think most people our age remember well the HIV scare of the 80s and 90s. That would be a retrovirus. There are lots of them. It's not just that one. So that's kind of the question. How do you explain endogenous retroviruses in the human genome? And so for the evolutionary model, the idea, I think, would be that in the past, we have been infected by retroviruses. And one of the interesting things about a retrovirus that it does, when the virus infects your cell, comes in as a piece of RNA, right? Plain old ribonucleic acid, RNA. And there is an enzyme that it contains. There's a gene that it has that produces an enzyme called reverse transcriptase, or RNA-directed DNA polymerase. Basically what it does is it takes that RNA sequence and turns it into a DNA sequence. And with DNA sequences, then it integrates into into the genome of the infected cell. And so that's one of the reasons why it's really not feasible to cure you of a retroviral disease, because it's always going to be somewhere in those infected cells. The only way to do it would be to kill the infected cells, which is difficult. So the evolutionary model would simply be that, over the millions of years that life has evolved on this planet, we've been infected by retroviruses lots of times. And so we all carry around this baggage of these old retrovirus sequences that are just broken down old pieces of infections that we had long time ago, whatever. Now, as creationists, of course, we're going to come at that question really very differently. And so then the question is, why would God make our genomes full of retroviruses? That doesn't sound like a good idea. And the answer is, I'm not sure we know exactly the answer yet. And I'm just going to leave it at that. I don't want to get too speculative here. But the question here, I think, is a really interesting question. Because the question is, could the bad ones have arisen as a result of the curse on the ground? So I'm going to interpret that broadly, because I don't think the curse on the ground had anything to do with it. I think the curse in general, the curse on creation itself, at Adam and Eve's sin, I think that very well could have something to do with the origin of viruses, or the origin of detrimental viruses. And the idea that humans were carrying around this reservoir of viruses that could escape sometime later and infect us and give us diseases, that's a very interesting idea. And there was a time about 20 some years ago when I was very excited about that idea. And I thought maybe all viruses escaped from other creatures. So I went, and this was back in the day when there were not as many sequences in GenBank as there are now, because now it's insane. But back in the day, you could download all the viral sequences, and you could download the human genome, and you could do the comparison to see if all the viral sequences were in the human genome. And it turns out, no, not really. It's just retroviral sequences. It's not a lot. It's not a lot of other viruses. So, yeah, maybe that was a stupid experiment to begin with, because not all those viruses infect human beings. So I don't know why you would go looking for a plant virus in the human genome. But it's an interesting idea that has occurred to me in the past, and I think the jury's still out. I think we're still in the early days of understanding virus origins and viral development over time. And so I'm just going to say, that's interesting. What an interesting idea. Someone should probably look into that more, and I'll leave it at that.
Yeah.
How's that for a
good.
safe answer?
Very, very, very good. We should maybe come back to viruses and ERVs and all of that in future episodes. That's a really interesting topic. Okay, let's go back to a geology topic. So we got lots of questions, I think, about our series that we did a while ago about where is the end of the flood in the geological record.
Oh, yeah.
This is a topic of perennial interest to creationists, and we had quite a few questions about that. Someone wrote and said, if the Ice Age immediately followed the flood, wouldn't the Cenozoic, now the Cenozoic is the most recent part of the geological column, right? But that's, in conventional terms, you can think of it as like the last 65 million years, basically. It's the time since the dinosaurs disappear from the record. So if the Ice Age immediately followed the flood, wouldn't the Cenozoic have to be very rapidly deposited? How could the Ice Age have been delayed? So I think the assumption behind this question is that kind of the flood ends, and then the Ice Age happens very quickly after the flood, which is the view of, some creationists, that they tend to think of the Ice Age as really it's the only major event after the flood.
And it's right away. No one gets
right
off
away.
the ark and it starts snowing.
Yeah. And it's very quick. I kind of want to turn that question around, right? So the time between the flood and probably the onset of the Ice Age, it could have been something like 300 years or so, I suspect, given, it depends, doesn't it, on your particular view of post-flood chronology, but let's say kind of 300 years or so, maybe a bit longer, depending whether you like the Masoretic or Septuagint chronology. One of the things we know about the Cenozoic, as we look at the kind of geological trends through the Cenozoic, the fossil trends in isotopes, in the sediments through the Cenozoic, and in ice cores and so on, is that the Cenozoic seems to be a time of global cooling and drying overall. That there is a kind of secular trend in that direction. There are different excursions where things warm up a bit and cool down again, but overall there's this kind of global cooling and drying trend, which then culminates in the growth of the ice sheets and glaciation.
Right.
But what's really interesting is that Steve Gollmer at Cedarville University has sort of done some recent modeling of a creationist ice age.
Okay.
And he's sort of started to sort of carry on. Well, he's sort of carrying on the work of Larry Vardaman, who'd done work along these lines at ICR back in the day. And Steve has sort of taken on the mantle of sort of doing this modeling work. And one of the things that Steve has become very clear, as we've listened to his talks on this over the years and his modeling efforts, is that he's finding it actually quite hard to get the ice sheets growing immediately after the flood because things are too warm to begin with. Things are too hot. Because during the flood, you have all of this tectonic activity and volcanic activity and the replacement of the ocean floor. And if you have very warm oceans, which is one of the things that you kind of need, because you need warm oceans to produce lots of evaporation, to pump lots of moisture into the atmosphere that can then eventually fall as snow and ice. You need that. But what he's finding is that immediately after the flood, things are so warm that it's not falling as snow and ice. It's not accumulating as ice. So he's saying actually there is this kind of delay. There's got to be a cooling down of the earth before you can begin to get the snowfall that will then compact and produce ice sheets. And some people have been sort of rather disconcerted by this. I actually thought, well, this is kind of what we might expect. Because if the end of the flood is around the end of the Mesozoic, beginning of the Cenozoic, there is a sort of time delay between Noah coming off the ark, the end of the flood, and when the ice sheets form. There is this sort of period where actually things are warm and wet, and it takes time for things to cool down, dry out, and eventually get cold enough that snowfall begins to form the ice sheets. So rather than the question being how could the ice age have been delayed, I think the question from the most recent modeling is how long is it going to be delayed? Can we get it started early enough?
Yeah.
So I think, I think that's a different way to look at that question. I'm not perplexed by the delay. It's kind of what I expect from the geological record of the Cenozoic.
And I would add to that, there's also the time scale issue, right? So I often find this when I talk to people who sort of accept the conventional time scale, there's a real disconnect. You say the flood ended in the fossil record approximately, at the end of the Cretaceous. And they're thinking, oh, well, then the Ice Age is 65 million years later.
Right.
No, it's not.
No. Yeah.
Because as creationists,
a few hundred years later.
Yeah, as creationists, we're thinking, okay, there's a big compression on this conventional time scale. So it's a really strange thing. It occurs also when I talk about Homo erectus and Neanderthals, because, for especially erectus, where you have, 1 million years of cultural stagnation. They're making little hand axes 2 million years ago, and they're making hand axes 1 million years ago, and they haven't advanced at all in 1 million years. And that sounds pretty bad. I mean, that doesn't sound very human. That sounds pretty inhuman. But when you think, oh yeah, so 1 million years, 2 million years ago is maybe a week, maybe a month. It's not much cultural stagnation at all. In fact, people making the hand axes could be also the people who are now making, Mousterian technology or something like that. It's not a long cultural stagnation. So there's all these unconscious biases that go into these questions that I think are really interesting to sort of tease apart. So
yeah, that's a good point. Yeah, next question.
All right, well, let's see if we can come up with another question here. This one cracks me up, but in a good way, because it's very insightful. Possibility. This is probably going back to our snake episode, our venomous snake episode. Yeah. Possibility. Venom was originally designed to be a digestive fluid to help ingest fruit, plants, etc. Does venom have any digestive properties? I'm going to be real hesitant about talking about snakes eating fruit and stuff. All the snakes that we have that we know about pretty much are carnivorous. They're hunters. And, to imagine them eating fruit. Maybe. Maybe. It reminds me of people trying to tell me, T-Rex teeth are for breaking open melons and stuff.
Oh, yeah.
Okay.
Yeah.
I don't know. I don't know. Maybe ancestral snakes, within the same created kind, whatever snake kinds there are, maybe those were different enough to be able to do that. But I'm not sure about snakes as we know them. But this question here, does venom have any digestive properties? This is one of the most intriguing things about venom, I think. A lot of venom proteins are not special at all. And this, I think, is something that people, I don't know if they fully appreciate this. When you think about a venomous snake and all the amazing attributes of the venomous snake, the hollow fangs and the glands that produce the venom, and then the tubes that run down into the fangs and then deliver the venom. It's beautifully designed. And then you add to it something like, pit vipers, pit that can detect heat. It's amazing. But the venom itself looks like it was just patched together from other enzymes, and especially from digestive enzymes. So could it be, does venom have any digestive properties? Yes, it absolutely does. That is exactly what it is. A lot of the proteins in venom are digestive proteins being injected into the animal, and they're special versions of the digestive proteins. So they go after specific molecules in the living animal's body. And those specific molecules, you got they attack the blood and it causes the blood to break down, or they attack the nerves and cause you to go into paralysis or something like that. But ultimately, those enzymes are in fact digestive enzymes, which I think is fascinating. So so even as we look at the snake and go, wow, this is a beautifully, brilliantly designed animal to do what it does. When you look at the venom, you realize, oh, this looks like it's been put together from other things. And, it's not really a unique or remarkable, separate sort of a thing. It's just digestive enzymes, basically, and other sorts of enzymes. But yeah, that's what it is.
Yeah.
So there you go.
Yeah.
Does it have digestive properties? It does. Could snakes eat fruit, plants, etc.? Not these snakes.
Yeah.
And
these snakes.
I'll leave it at that.
Yeah. That's interesting. It is fascinating. It is so hard to try to imagine what that pre-fall world was like, and we do sort of feel like we're looking through a glass darkly, to try to sort of unravel some of that. Anyway, let's come on to another question. Now, this is not a geology question really, but partly, but it's also biological. So this, I'm sure you've got some thoughts about this one too. Somebody asked, could animals have returned to their place of pre-flood origin because of migration or homing instincts? Could God have divinely ordained that they return to their place of origin, just as he ordained them coming to the ark? So I think that the question has sort of arisen here because I think when we had Marcus Ross on the program, we were talking about the end of the flood.
Yeah.
One of the issues with one of the problems with having a flood boundary very high in the record is that you have lots of animal taxa that kind of cross the boundary.
Yeah.
That you find them in the same spot on the Earth's surface.
That's right.
Below and above the boundary.
That's right.
And
that seems implausible.
It seems implausible because they would have to be buried in that spot during the flood. And then after the flood, the descendants of the survivors on the ark would have to re-migrate back to the very spot where their ancestors were buried.
And it has to happen all over the earth. It happens
all over
everywhere. Every kind of animal does that. Yeah.
Yeah. Which seems incredibly implausible.
Very ad hoc.
So the question here is, could it be explained by some kind of migration or homing instinct? So they're sort of just returning back to their sort of ancestral point of origin. Now, I mean, that's an interesting question. The problem with that is that the flood itself was a very dynamic event. And if we're right, the continents were rearranged. The continents are no longer in the same position that they were before the flood. Ocean basins have opened up and separated continents. And so to get animals coming off the ark and through homing instincts going back to the very spot where their pre-flood ancestors not actually happened to be living, but just happened to be buried during the flood, that doesn't really make very much sense, particularly given that that piece of crust would now be in a different latitude, longitude, a different climatic zone than it was before the flood. So that seems problematic. What about homing instincts? We know that animals have homing instincts. They're able to migrate. They're able to use the Earth's magnetic field to migrate, to navigate. Could that explain why animals are going back to the place where their ancestors were buried? Well, again, the continents have moved around. They're not in the same place. Not all animals have these particular instincts and abilities. And then the question also brings up this idea of being divinely ordained. Maybe it was just a miracle. Maybe they were just divinely ordained to just sort of go back to these spots. And I mean, this is possible in the sense that God can do anything. I mean, if he had chosen to do that, he could have done it. The question I would ask though is, why would he have done it? Is there any reason for us to think that that's what happened? There's no biblical statement to that effect, like there is for, say, the gathering of the animals to come onto the ark. So I'm sort of wary of inventing a miracle to explain why there's continuity in the fossil record, when actually there are alternative explanations for that that explain the data without the miracle. So, I'm not sure that any of these are solutions that really work. Now, I don't know if, as a biologist, whether you have any.
I think you've said it just fine. I mean, I think people have a really hard time wrapping their head around the planet that existed before the flood is gone. That effectively. I mean, it's the same lump of rock orbiting the sun, true, but the entire continental configuration is completely different. And with it, all the climate zones and everything is totally different. So the idea that they would know how to migrate back to where they were, no, because they're not going back where they were. It's a completely different place now.
Yeah.
So, And as to the issue of could it be a miracle? Yeah, but you're just creating a miracle to rescue a hypothesis that isn't very good in the first place. And you shouldn't make miracles to create bad hypotheses. You should just say, you know what, this probably doesn't work, and maybe we should get rid of this miracle because the Bible doesn't say that it happened. So
no.
I'm not really proposing it for a very good reason. I'm just proposing it to rescue my favorite.
Yeah, to rescue. Yeah.
My favorite theory.
Mm-hmm.
Okay. Shall I go on to another one here? I guess we got a couple of minutes to do another one at least.
Yeah.
How did human skin colors and other traits arise after the flood? And is this reverting now that we can travel worldwide and intermarry? Okay, so first question. How does human diversity arise after the flood, and particularly biological diversity? So the first thing I think we should mention, there's so many first things I could mention. The simplest answer is, I think, we don't know, sort of. We don't know, for example, how diversity within the humankind arose. We are able to identify what is human and what is not human, for the most part. And so, in my mind, the big question, of course, is, well, how do you get a Neanderthal, right, from Adam and Eve, right, or from Noah and his family? And that's challenging. We have Neanderthal genomes. We have a lot of information about Neanderthals, and yeah, that's a really interesting, puzzling, difficult question. Now, I think, though, this comment is really more about modern ethnic diversity. How is it there are people with dark skin, and how is it that there are people with light skin, and so forth? And that we know from studying the human genome. For example, let's just take, for example, skin tone, the color of our skin. We're pretty pale here on this podcast, Paul.
We're on the pasty end of the spectrum.
We are, yes.
Yeah.
And we came by, honestly, being I'm nearly entirely British in my genome sequencing, ancestral, whatever it is. So British and Northern European. So that's this. This is what you get there. So here I am. But it's largely mutation. We know there is a gene called MC1R that is responsible for pretty much 80% of variation in human skin color. MC1R, for you really big cell biology nerds, it's a 7-transmembrane receptor protein in the G-coupled receptor family. And so we know these kinds of proteins that may have a gibberish to you. Sorry, Paul, I just started speaking in tongues there. These kind of proteins, they're synthesized to sit in your membrane and act as signals. So they receive a signal from the outside of your cell, and they tell proteins inside your cell what they need to do. And MC1R is basically telling the cell to produce melanin, which is our principal molecule of pigmentation in human beings. So people with very, very, very dark skin produce an enormous amount of melanin, and people like us, Paul, we produce not very much melanin. Yeah. So what's the deal? Why would that variation exist? And the variation exists because there are different versions of MC1R, and we know that they're mutant versions. So, for example, we know there are MC1R that essentially does not carry the signal into the cell very well at all. And we can tell this purely by cell biology experiments. So this isn't just me hand waving. This is, you can compare different types of MC1R, and you can see, well, this one signals well, and this one signals poorly. And the ones that signal normally produce sort of a mid-range, medium brown type skin. You can have some that are turned on way too loud, if you will, way too high, very actively telling the cell to produce melanin. Those are the ones that are producing the very, very black skin. And then the ones that don't work very well at all, but receive the signal, or they don't receive the signal, or they receive the signal and don't transmit it very well, they're the ones that produce the sort of pale skin. It is not correlated, in case you're wondering, it is not correlated with anything that traditionally people think of as race. So if you look into this is part of what we've been working on for the book that we're working on. I did some research into history of race, and it's fascinating that basically the races, the African and Asian and European basically invented. It's not really based on biological reality. It was a conceit that was invented in the 18th century. Convenient way to try to classify things, but it really wasn't biological. So in fact, skin tone in all three major, European and African and Asian and even American natives, skin tone varies by latitude primarily. So higher latitude people have pale skin, and lower latitude towards the equator have darker skin. It's that simple. So are these differences going to disappear here in the world in this modern world where we have world travelers going around and meeting people from different cultures and getting married? Probably not, because the genes still exist, right? So we're not in a world of blending inheritance where you mix two people together and you get a blended, sort of halfway in between sort of phenotype. That generation has the genes for both pale skin and for very dark skin. And so it's not, those genes haven't been lost, and they haven't been altered either. So it may be, and we definitely see this, that certain ethnic groups might disappear, or they might become very dominant in a particular geographic area. But the idea that the biological differences, which oftentimes is very trivial, those aren't just they're not gonna disappear. They're still here around. So there you go. Now 7 transmembrane receptor proteins. Woohoo!
Yeah, interesting. No, that's very helpful. How long have we got left? I'm just thinking, how many more questions?
Why don't we do one each, and we'll call it good enough.
One each. That sounds good.
I mean, we probably should wrap it up, but one each sounds fair enough.
We've still got loads of questions on our list. We
this
never
is
get
the problem,
to our list,
right? We never have enough time because we always have other
we
interesting things to talk about in the podcast. So.
I know. Anyway, I'm going to tackle this one because although it's not a kind of directly in some ways a creation question, I thought it was a fun one. What are your thoughts on cryptids? Is the question.
You mean like Sasquatch and Yeti and the Loch Ness monster?
Yeah, well, this is the question, isn't it? So cryptids, for those who are not familiar with that word, are animals which their existence or their survival is disputed in some way or unsubstantiated. And I think when people think about cryptids, they do immediately think of the kind of spectacular examples: Sasquatch, Bigfoot, Loch Ness monster, sea serpents, this kind of thing. But strictly speaking, if you want to sort of be very, very sort of mundane about it, we could be talking about any animal whose existence it has not been confirmed. So a fish could be a cryptid, or a small lizard, or a type of mouse, or a whale. Any of these things could be cryptids. And in that sense, what do we think about cryptids? Do they exist? Well, in that broader sense, I think we'd have to say yes, they do, because there are undoubtedly new species that we have not documented. New discoveries, new descriptions of species are being published in the scientific literature all the time. This is not particularly uncommon, and at least some of these species were suspected. Their existence was suspected before their discovery. Perhaps they were, mentioned in local folklore, or perhaps sort of the natives of a region knew about them before the scientists did, or whatever. So you could say, well, yes, I mean, those are cryptids. But I think when people ask this question, they are thinking, aren't they, about those more spectacular, unexpected animals like Bigfoot and so on. So what do we think of that? Well, I mean, speaking personally, I think it's worth keeping an open mind. We're not dealing with something that is completely fantastical in the sense of, we're not saying, could there be fairies? We're talking about undiscovered animals. So in that sense, I think, we should keep an open mind. And I've always been intrigued by the subject. I've actually got quite a few sort of books on cryptozoology. But generally speaking, the more sensational the claim, the more skeptical I am, is how I would put it. So I would love for there to be a surviving plesiosaur in Loch Ness. But I don't think there is.
Yeah.
I don't think that's what people are seeing.
Right.
I would love for there to be a very large undiscovered bipedal primate walking around North America.
Sure.
Is there? Well, I mean, I think something like that is more likely to turn up in a part of the world like Sumatra or some sort of more far-flung place than perhaps in North America. But I suppose at the end of the day, I'd say never. I would love to be convinced. I would love to be surprised. And thinking about, for example, the discovery of the Hobbit, Homo floresiensis on the island of Flores. Could there be some undiscovered species of primate or something like that living in some remote part of the world? I think it's possible. I don't know that I'm convinced, but I'd love to be proved wrong. So that's kind of how I put it. And I do think we ought to do a Loch Ness episode sometime. So if you're if you're able to come over here at some point, Todd, to the UK, we should definitely try and make a trip to Loch Ness, because I think there's a really interesting episode to be done there.
Well, that relates to my last question here. So can we have Todd go to the UK for another series?
Oh, wow. Yeah.
What do you think, Paul? Should I come over there this summer?
I think you definitely should.
Okay.
We'll leave people on tenterhooks, but yes, it would be great to have Todd here and to do some things together on this side of the pond.
Yeah.
And reciprocate, because I've obviously been over to the States and we've recorded
Several times.
podcasts there.
Yep.
More than once, and there are definitely some interesting things we could do here. So it is on our agenda. Let's say that.
It is definitely on our. The difficulty I'm going to have is picking out what we're going to do, because I could easily spend 2 or 3 months over there.
Right.
Just traveling around and doing this episode or that episode. We're going to have to narrow it down. Loch Ness sounds like a hoot.
Yeah, well, that would take some planning, but we're going to have to do that sometime.
I've been there, I visited Loch Ness.
Have you?
Yeah. 25 years ago, I guess it is now. I went to Urquhart Castle and went down to the shore there and looked at this boat went by. You know how how you read the skeptic literature and they're always saying, well, there's these boat wakes that look like sea serpents, right?
Mm-hmm.
So this boat goes by. I'm just standing there watching it. And it was fascinating because because Loch Ness is so narrow, and the boat goes by, and the wake just goes back and forth and back and forth and back and forth, long after the boat's long gone.
Yeah.
The boat's gone.
Out of view. Yeah.
And yet the water is still stirred up by just reflecting back and forth and back and forth. It was quite interesting. So suddenly it seemed like the skeptic was less implausible than it seemed at first glance when I'm reading about it, going, that seems crazy.
Yeah.
Anyway.
No, we'll have to do that. And there is an interesting geological story at Loch Ness as well. So there's some fun things we could do.
Yeah, there's more to it than just non-existent plesiosaurs. There's quite a lot of interest, because the highlands are the Appalachians, effectively. I mean,
that's right.
It's an extension of the Appalachians. So where I live here on the edge of, just an hour or so from the Appalachians, Yeah, that's basically same as the Scottish Highlands.
That's the Scottish Highlands. Yeah, it's an extension of the same mountain belt. Yeah,
Yep,
absolutely.
And we could talk about that.
We can
when we do that episode.
Yeah. Anyway, we'll draw it to a conclusion there. That's been a fun episode. We've still got loads and loads of your questions, and we're going to have to come back and do another episode. And we've accumulated more questions since we compiled this list.
Yeah, yeah.
Anyway, we'll get through as many as we can. Thanks for joining us. We'll see you in a couple of weeks' time, and we hope you'll join us again then.
See you around.
Thanks for listening to this episode of Let's Talk Creation. For more information, visit us at letstalkcreation.org, where you'll find an archive of past episodes and all our show notes. If you'd like to leave a comment or make a suggestion, you can find us on all the major social media platforms. Let's Talk Creation is brought to you in the U.S. by Core Academy of Science and in the U.K. by Biblical Creation Trust. As a listener-supported ministry, we are grateful for all of your financial support. Find out how you can make a contribution at our website, letstalkcreation.org. Also remember to like, subscribe, and share this episode with your friends. Thanks, and see you next time.